So reducing double angle expressions is just the mother of all trigonometric identity problems. So you start with something like this. 2 over tan of 2 alphas equals this minus that. And I need to show that that's true. So I've written over here the grand toolbox of things you have to work with. There's the double angle identities for sine, the double angle identities for cosine, including these two wonky ones that you were supposed to show were true in the assignments. And then the fact that tan of anything is sine of that thing over cos, and the good old Pythagorean identity that sine squared of anything plus cos squared of the same thing is worth 1. So I'm going to look at this, and just as a suggestion, and it doesn't, you don't have to do this, but just as a suggestion, get rid of tan first. Always do that. Gets it out of your hair. Second, once you've gotten rid of tan, you're going to get rid of the double angle identities, which will boil this more complicated thing down into just a trig identity for us to solve. So if I were to do that, I'm going to get rid of that tan 2 alpha. I'm going to just work on the left side here for a minute. I'm going to write that as sine over cos. Now that's bad form. So you shouldn't have a fraction and fraction. If you are dividing by a fraction, you're supposed to like flipper. So 2 divided by sine, and then divided by cos. The double division flips it to a multiplication. So this thing looks like this. Now that little operation had nothing to do with the fact that there's sines and cosines. That's just fraction rules. So if it seemed a bit arcane, you just double check that like 5 divided by 1/2 is the same as 5 divided by 1 times 2. Right, so how many times can you fit half into 5? Well, half, then 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. You can do it 10 times, which is the same as 5 times 2. So that's sound. Now that I've gotten rid of this tan, I see I've got a cos 2 alpha and a sine 2 alpha. So I'm going to go up here and I'm going to find sine 2 alpha. There's only one option for that, so I'm going to use that one right away. Yeah, here, take up my space. So instead of sine 2 alpha, I'm writing 2 sine alpha cos alpha. There it is. Now up here, for the cosine of 2 alpha, I can choose this one, or I can choose this one, or I can choose that one. So you have to be a little tactical here. If I were to choose, well, I don't know. I've got a choice here. I'm not sure. So I'm just going to leave a question mark there. We'll come back to that. Maybe we're going to work on the right side here for a bit. I have a fraction minus a fraction, and you can't do that unless you have common denominator. So we're going to use common denominator on this thing. I already have a sine alpha in the denominator here, and I have a cos alpha on top, and I have a sine alpha on top and a cos alpha on bottom for this one. To make these denominators match, this one needs a cos, this one needs a sine. So I'm going to do that. I toss in a cos alpha on top and bottom, and I'm going to toss in a sine alpha here. Alright, there's a 2 here, and then whatever I'm replacing the 2 alpha with. You notice that these two things divide out? Well, that's handy. So I'm left with whatever choice I make for that over sine alpha cos alpha. Now that's encouraging because that's the common denominator that I have here. So I'm going to keep working. I'm going to write these as one fraction. Cos times cos is cos squared. And sine times sine is sine squared over sine alpha cos alpha. Well, if I look in my list, one of the things I can replace cos 2 alpha with is cos squared alpha minus sine squared alpha. So if I did that, if I finally make the choice now that I've sort of seen where I'm going, then I end up with cos squared alpha minus sine squared alpha. So I've just shown that the left side equals the right side. And I'm finished. So if you go through the process here, I saw a tan and I got rid of it. And so that just eliminated one of the things I was trying to work on. Then I had these double angle identities. If I see sine 2 alpha, there's only one option. So I'm just going to dump it and come up with this one. The cos 2 alpha, I had some choices. So I just paused on that. I went and I worked on the right side a little bit, selected the algebra tool, maybe it's factoring, maybe it's common denominator, maybe it's something else exotic, in order to boil it down to this. And then once I got it to here, that told me which of the double angle identities to use in order to show that the left side was the right side. So another example of this little exercise. I have 1 minus sine twice alpha is cos alpha minus sine alpha, then squared. So going through the same process, if I had a tan, I would get rid of it at this point, but I don't. So I'll skip to the next step. I see a sine 2 alpha, so I can replace that with this, 2 sine alpha cos alpha. So I'm going to do that. Where's my marker? Well, let's do it in blue. No, I'll do it in green. So I'm going to write sine 2 sine alpha cos alpha instead of this expression here. That's my left side. I'm going to work on the right side over here a little bit. When I have a thing squared, that means it's the thing cos alpha minus sine alpha multiplied by itself. So I'm going to have to FOIL this. So cos alpha times cos alpha is cos squared. Cos times minus sine is minus sine alpha cos alpha. Minus sine times cos is minus sine alpha cos alpha. And minus sine times minus sine is plus sine squared alpha. Now, on this little expression here, I only have one cos squared. I only have one sine squared. Then I have minus sine cos alpha minus sine cos alpha. That's two of them. Well, that's encouraging because I have a minus 2 sine alpha cos alpha just sitting right here. Now, if only there was a way to show that 1 was the same as cos squared plus sine squared, and there it is. Way back from grade 11, you have that Pythagorean identity. So if I park that in on this side, 1 is cos squared alpha plus sine squared alpha minus 2 sine alpha cos alpha. Then if I do just a little bit of arranging, switch the positions of these two. Then I have exactly the same as I have on the other side. So I've shown that left side equals right side. So I'm done with the proof. So if you can keep calm and carry on, whenever you see a tan, get rid of it. Replace it with sine over cos, and then manage the fraction rules. If you see a sine 2 alpha like this one, you replace it immediately. if you see a coast to alpha, you're going to have to decide which one of these three is appropriate. And you can usually come to a decision by working on the other side a little bit to see which pieces of the structure pop out.